Hello, this is Reynolds Monach from Wagner Associates. Today I want to talk about a theater undersea warfare software system that we're developing that does multi-objective threat evaluation and prioritization, risk assessment, and risk mitigation. You can get an idea of how it works from the graphic below. It lists each of the threat submarines, shows the total risk from that submarine based on its capability, and also shows how that risk is reduced by current search. In addition, it has the capability to look at risk based on intent, to look at this from a friendly asset point of view, where each asset is shown along with any threat assets that are a risk to it. And in addition, to mitigate risk, it can recommend search strategies that can reduce the risk to specific assets. Daniel H. Wagner Associates has been doing operations research, mathematics, and software development, primarily for DoD clients, for over 58 years. In particular, we have applied sophisticated mathematical techniques to solve challenging and difficult Navy problems. We've been very successful at applying these techniques well enough to transition to Navy programs of record in two key areas: mission planning and threat mitigation, which is what this particular SBIR relates to the most, but also we've done a lot of work with tracking and data fusion. Some of the examples of our mission planning transitions are the mission optimization configuration item and the operational route planner, which went through OPEBAL in 2013 as part of the Undersea Warfare Decision Support System. The acoustic mission planner on all of the MH-60 Romeos that's used to plan all of the dipping sonar and sonobuoy searches on the helo, and went through OPEBAL in 2005. The submarine route planner to minimize mine risk went through APB 09, and the environmental data fusion and search effectiveness evaluation and optimization modules in MineNet Tactical, which is the Navy's primary mine warfare planning system. Some of our tracking and data fusion transitions are into USWDSS, into many different types of unmanned surface vehicles, including participation in ONR swarm demonstrations starting in 2014 and continuing through 2020, and our torpedo defense data fusion system, which went through ACB 13 for the SQQ-89A. The key personnel on many of these projects was myself, and I have extensive experience in designing, developing, and evaluating target localization and mission planning and search optimization algorithms. In this SBIR, our key focus is on automatically and continuously reducing the risk to friendly assets by generating a prioritized watch list based on detailed, accurate risk computations that account for all the relevant factors. This allows the theater undersea warfare watch officers, and in particular their current operations and future operations teams, with accurate situational awareness, alerts concerning increased risk to friendly assets, and recommended responses to that risk, which could be repositioning search assets, obtaining additional search assets, or potentially rerouting friendly forces. The initial transition will be into USWDSS, which is the Navy's undersea warfare planning system. And one particular reason we need to do this is that manually maintaining such a watch list, which all of the TASWACs tend to do, is difficult and complex, especially in a cluttered environment. And as if you have a very large number of threat assets, it's very difficult to do it manually. This operational need exists because there are many modern, stealthy, and offensively capable submarines that pose increasingly difficult challenges for USW, and therefore we need to improve how we track those submarines and reduce the risk from them. A key way to do that is to produce a prioritized watch list, which is what this project is doing, and this will allow the Navy to deal better with the increasingly large numbers of near-peer submarines. In addition to USWDSS, we expect that this technology can benefit the entire Navy in particular, but also other DoD elements through foreign sales of USWDSS, the Aircraft Carrier Tactical Support Center, which is another IWS 5E program, the FFGX, MTC2, D6N, PEO sub, and Commander Undersea Surveillance, all of which have the same problem with a cluttered environment facing larger and larger numbers of near-peer submarines and needing to utilize the assets that they have as effectively as possible, and to reduce risk to friendly assets as much as possible. This slide shows an overview of how theater undersea warfare is conducted. At this point, I'd also like to thank my subcontractor on this project, Current Technology Group, which has provided a lot of real-world expertise to the development of this project, and in particular put this together. They have a great deal of experience in the theater undersea warfare world, and also with developing intuitive systems that are very effective when used by the fleet. And so that is a key reason why we feel this system will be very successful in practice and will successfully transition. The process begins with planning, where you develop probabilistic enemy courses of action and potential friendly courses of action. You typically brief that information to the battle watch captain. You execute and replan, monitor the effect all of your actions have on the picture, generate any code as necessary, debrief to say, what did we learn about the enemy, and how did our planned actions work, and then go back and replan. We feel that TMTP will support all of these phases. So the initial plan will be based on the watch list showing, okay, what are my potential threats? That will provide briefing materials. TMTP will continuously monitor progress and monitor information about the threats. Their itch products can be fed into the debrief, and they will be part of the assessment. And so we think that TMTP analytics, will become a key part of the overall theater USW process and make the overall process much more effective. The current status of TMTP is that we are continuing to develop a concept of employment, watch list databases, alerting criteria, risk calculation algorithms for evaluating and recommending modifications to planned friendly courses of action to reduce risk, and operationally relevant scenarios. Moving forward, we have an initial prototype that we're going to have fleet evaluation for within the next few months, that will then lead to a full prototype demonstration by the first quarter of FY23, and an external evaluation by the fleet and IWS 5E. Finally, it will be integrated into USWDSS and other Navy mission execution systems. Some of the key features, advantages, and benefits of TMTP are automated mission execution and monitoring tools to assist and inform Navy operators, along with recommended responses to any threat actions. Greater situational awareness and reduced vulnerability due to automatically and continuously quantifying potential risk from threatened undersea vehicles, and automatically recommending more efficient and effective use of limited USW search assets accounting for acoustic conditions and anticipated target behavior, which should result in a higher probability of detecting threat platforms, thus reducing risk. For this project, we have a very clear transition plan, which is to transition to USWDSS at the completion of the Phase 2. And our current sponsor is NAVSEA PEO IWS-5, which would also sponsor the transition. As I mentioned before, we also have a number of additional transition paths through USWDSS foreign sales, CBTSC, the FFGX program, MTC2, D6N, PEO sub, and Commander Undersea Surveillance, because all of them deal with the same problem of having a difficult operating environment in which they need to determine what the risk is from all the threat assets and how they can best mitigate it. In addition, the other DoD services have similar issues in terms of determining which threat assets present the most risk and how they can be countered. So we think that this technology can have applications throughout all of DoD, and also potential commercial applications in areas such as harbor security or border security. We're interested in you talking with us about any problems you have that might be solved somewhat, at least, with the technology we're putting together. Obviously, the current technology is related to anti-submarine warfare, and a very similar approach could work with anti-surface warfare. However, the key overriding approach is that we have software that monitors a common operational picture or common tactical picture, calculates risk from whatever threats might be present, and then determines how best to mitigate that risk. And that is clearly a much more general application that might be useful to many other projects, and we're always looking for new applications. We can definitely discuss, any further technical details you're interested in, both related to, anti-surface and anti-submarine warfare, but also a, completely different area. And we have definitely designed it to be modular and loosely coupled, taking a modular open systems architecture approach. So we feel that should make integration into any system relatively straightforward. It also is not incredibly CPU intensive, although it certainly is doing a reasonable amount of computation. And we feel both of those factors should make it relatively straightforward to integrate into many other systems. The point of contact is myself, but if you can't see me at this venue, then feel free to contact me by phone. My cell number and office number are given below. Thanks very much, and I hope to hear from you.